All right, this is a refresher of a few skills that we will need for Chapter 5. So, first off, factoring. To factor a polynomial, remember we look for two numbers that multiply to give me 90, and they need to add to give me this center term, 19. Well, I know to get n squared, the only way I can factor it is with n and n. Two numbers that multiply to 90 and add to 19 are 10 and 9. So n plus 9 and n plus 10. There's my factored version. This time, remember that we always start with a GCF, the greatest common factor. What can go into both of these terms? N can. If I take an n out of n squared, I'm left with n. If I take an n out of 2n, I'm left with a 2. That minus stays there in the middle, and there's my factored version. Now to factor, same thing as we were doing just a moment ago. I'm looking for two numbers that multiply to give me negative 80, which means one of them must be positive and one must be negative. And I need two numbers that add to give me negative 2. Since I just have a p squared in the beginning, that tells me it'll factor into a p and a p. Things that multiply to negative 80, there's lots of options, but I want them to be 2 apart. Well, I know 10 times 8 is 80, and 10 and 8 can make a negative 2 if it's a negative 10. So there we go, minus 10 plus 8, and it's factored. And this fourth one here, to factor this, remember we start with the GCF. We take out a 3 from everything. That leaves me x squared minus 3x minus 4. Now we look for two things that multiply to give me negative 4 and add to give me negative 3. Well, I would say negative 4 plus 1 makes negative 3, and negative 4 times 1 makes negative 4. So I have x minus 4 and x plus 1. Don't forget that 3 in the front. Now we'll switch gears a little bit, and we're going to simplify rational expressions. So this first expression, I would start by saying, okay, what goes into every single one of these terms? Well, I can see that they can all be divided by 7, and they can all be divided by b. So essentially, I'm going to factor 7b out of the numerator. That leaves me with 10b. And I'm going to take a 7b out of the denominator. That leaves me 3b plus 5. Now those 7b's cancel, and I'm left with 10b over 3b plus 5. The other trick to this is saying what b could not equal. Anything that would make your denominator equal 0. So what things make my denominator equal 0? Well, remember, it's already factored, so 7b equals 0 or 3b plus 5 equals 0. b equals 0 would make the denominator 0. And subtract 5, divide by 3. b equals negative 5/3 would make the denominator 0. So remember, this work is just telling me what b cannot be. So we indicate that here, b doesn't equal 0, and b doesn't equal 5 or negative 5/3, because that would make me divide by 0 at some point in the problem. All right, same thing on this next one. I'm going to start by factoring. I'll factor the numerator. All I can do in the numerator is take out the greatest common factor, which is 7. Leaves me x plus 7. And look at that, they both have an x plus 7. In order to cancel things in a fraction, it needs to be the entire factor. Boom, we're left with just 7. But we have to say what x can't be. What would make my denominator 0? Negative 7 would. All right, this one, we are subtracting two fractions, but they don't have the same denominator. So here we go. We need a common denominator. When in doubt, you can multiply each fraction by the opposite fraction's denominator. So we'll multiply this first fraction by 2v. Multiply the second fraction by v minus 2. Remember that there's invisible parentheses around each of those. So I get 4v squared over 2v times v minus 2 minus 5v times v minus 2 over 2v times v minus 2. I'll combine these into one fraction, and I'm actually also going to distribute here at the same time. 4v squared minus 5v squared plus 10v. Remember that this minus is getting distributed with the 5, so it double negative makes plus. And the denominator is just 2v times v minus 2. Combine my like terms in the numerator, I get negative v squared plus 10v over 2v times v minus 2. Well, my numerator has a common factor that I can take out. I can take out a v. And leaves me negative v plus 10 over 2v times v minus 2. And now I can cancel this v from the numerator and denominator, leaving me negative v plus 10 over 2 times v minus 2. Now we say what v cannot equal. V can't equal 2, but make sure you look back in the problem because 2v was in the denominator as well, which tells me that v can't be 0. And look everywhere in your problem, there's no other issues. There we go. All right, same thing for this one. We start off, we need a common denominator. So I'm going to multiply the first fraction by m plus 3. And I'm going to multiply the second fraction by m minus 5. So in my numerators, I have 3 times m plus 3 over m plus 3 times m minus 5 plus 6 times m minus 5 over m plus 3 times m minus 5. I'm not going to actually multiply out my denominator because it'll make my life harder in the long run, but I am going to multiply out those numerators because I need to combine them. So I have 3m plus 9 plus 6m minus 30, and I'm going to combine it all into one fraction because I can already tell they have the same denominator, m plus 3 times m minus 5. Combine my like terms, I get 9m minus 21 over m plus 3 m minus 5. The only step further we could take is to take the GCF out of the numerator, and that's just a 3. Leaves me 3m minus 7 over m plus 3 times m minus 5. No factors cancel, nothing like that. So I just say m cannot equal negative 3, because that would make m plus 3 0. And m cannot equal 5, because that would make m minus 5 0. Notice I do not care about 7/3, because that makes the numerator 0, which is okay. All right, for this next one, we're gonna get a common denominator. I actually, though, noticed that this fraction right here, the 2's can cancel. So I have 3 over m plus 4 minus m. It's secretly over 1. So I really just have to multiply this second fraction by m plus 4. And then I'll have my common denominator. So I have 3 over m plus 4 minus m times m plus 4 over m plus 4. Common denominator, let's distribute. 3 minus m squared minus 4m over m plus 4. And I would factor out that negative, giving me m squared plus 4m minus 3 over m plus 4. Now I say, can I factor the numerator? I don't think I can factor that. So I just say m can't equal negative 4. Make sure there's nowhere else that I had a variable in the denominator, and we're done. All right, for this next one, I'm going to go ahead and say I should factor things and try to simplify before I do anything else. Because in the first fraction, I can cancel out those 2's. Leaves me just a. In the second fraction, I have 6a over, I can factor out a 3a, leaving me a plus 1 in the denominator. I can cancel out the a's. I can simplify the 6 over 3, So I have a plus 2 over a plus 1. Now I'll get a common denominator because I remember that's over 1. Multiply by a plus 1. And parentheses there so I don't mess it up. I get a squared plus a over a plus 1 plus 2 over a plus 1. And combine just a step further, a squared plus a plus 2 over a plus 1. Can I factor the numerator? Not at all. So a can't equal -1 because that makes the denominator 0, and then we're done. And now into multiplying. When you're multiplying two rational expressions, you want to start by factoring everything. Factor every single thing that you possibly can. So I'll factor this first numerator. I get m plus 4 times m minus 1 over 6 times 6 over, I would start this second one by taking out a -1 because that makes it m squared plus 7m minus 8. Now I can factor that. So this first fraction is staying what it was. All right, I would do m plus 8 times m minus 1. Now I cancel common factors that I see. These 6's are common factors. M minus 1's are common factors. The rest isn't. I'm going to take this negative and just float it out front. M plus 4 in the numerator and m plus 8 in the denominator. Now I say what m cannot equal. Well, -8 would make the denominator 0 here. But I also had an m minus 1 at some point, so m also cannot equal 1. And there we are. And one more example here. Again, we're multiplying our rational expressions, so I want to factor everything right away. This first fraction in the numerator, I can take out a 2x times 2x plus 5 over x minus 6. Remember that x minus 6 is in itself a whole factor. Times x minus 6, again, a whole factor. Over, take out my GCF here, it is 9x, which is 2x plus 5. Now we cancel common factors. X minus 6 is a common factor. 2x plus 5 is a common factor. X is a common factor in the numerator and denominator, which leaves me just the 2 over 9. But we have to say what x can't be. 6 would make the denominator 0 there. 0 would make this part of the denominator 0. And here we'd have -5 over 2. Those are the values x cannot be. All right, your assignment will be the side that says assignment numbers 1 through 12.